So this video is going to get you ready for the Conics test. I've got my foldable that you'll get when you walk in that you had already made, and here's the review sheet. So the very first question says graph x equals 1 over 8 y squared. And I notice that only one variable is squared, so it's going to be a parabola. I open up my parabola section. Because the equation says x equals, I know it's going to be a left and right. Because it's a positive 1 over 8, I know that it's going to open to the right. So the next thing I'm going to see is that there are no parentheses here. Because there are no parentheses, the vertex is going to be at 0, 0. So I can go ahead and put a point at 0, 0. I remember also from my formula that the fraction out front, the denominator is always equal to 1 over 4 times a. So that means that 8 equals 4 times a, so a equals 2. And a is the distance from the vertex to the focus and from the vertex to the directrix. Because this one opens to the right, I can go ahead and do this. And then I'm going to go 2 units inside of the parabola, 1, 2. So that's my focus. So my focus is at 2, 0. And then I'm going to go 2 units the opposite way, so 2 left, 1, 2. And that is going to give me the line of what we call the directrix. Because it's a vertical line, the equation will be x equals, and I went left 2, it's negative 2. Number 2, it says y equals negative 1 over 12x squared. Again, only one variable is squared, so I know it's a parabola. Because it says y equals, it's going to be one that opens up or down. Because it's a negative, it's going to be a parabola that opens down. Again, we'll notice there are no parentheses here, so my vertex is at 0, 0 again. My denominator is 12, and we just said the denominator is always equal to 4 times a. That means a is equal to 3. Because this is a negative, it's going to open down. Remember, your focus is always inside the parabola, so I'm going to go 3 units inside, 1, 2, 3. There's my focus. That ordered pair right there is 0, negative 3. My directrix is always the opposite of my focus, so 1, 2, 3. There's my directrix. That's a horizontal line, and it's y equals 3. Number 3 wants me to write an equation of a parabola with a vertex at 4, 7 and a focus at 8, 7. So in order to write the equation, I need to know which direction it opens, up, down, left, or right, and I need to know my a value. So I'm going to do a little sketch to see if that helps me. So I've got a vertex at 4, 7, so 1, 2, 3, 4. We're going to say this is 7 up here. So there's my vertex. And then I have a focus at 8, 7. So that's 4, 5, 6, 7, 8. And here's my focus. Earlier we said the focus is always inside, which means this is the direction that I'm going to have to open. Because I'm opening to the right, it's got to be an x equals equation. So I know I'm going to have x equals. I'll notice also that my vertex is not at 0, 0, so I'm going to need some parentheses. When you have your parentheses, your y is going to go in here. And the y value at the vertex is 7, but we always write the opposite when I go in the parentheses. Outside the parentheses is going to be your h value, which is the x coordinate, which is plus 4. The only thing I have to know now is what fraction goes out front right here. Remember, we said it's always 1 over 4 times a. So if I can find a, I'll know what goes right here. So a is always the distance between the vertex and the focus for parabolas. If this is 4, 7 and this is 8, 7, a is equal to 4, which means my fraction out front needs to be 1 over 16. I didn't give myself a lot of room to write there. So that's 1 over 16, y minus 7 squared plus 4. Number 4 wants me to write the equation of a parabola again, so I'm still using this part of my foldable with the directrix at the line y equals 1. So the line y equals 1 is a horizontal line. So y equals 1, and a vertex at the origin. So I'm not going to need any parentheses. Remember, your focus is always inside the parabola, but your directrix is outside. That means that I'm going to need a parabola that opens this direction. Because it's an up and down parabola, my equation needs to start with y equals. Because I'm at the origin, I don't need any parentheses. I just need to know what is my a. A is the distance from the focus to the vertex, or it's also the distance from the vertex to the directrix. So A is equal to 1. So out front, I need y equals 1 over 4 times A. We just said A was 1, so 4 times 1 is 4. Because I'm at 0, 0, I don't need any parentheses. I just need to go write my x squared. Okay, so that's everything we need to know about parabolas. The next section of the review was all about ellipses. Okay, so I'm going to go to my ellipse part of an ellipsis. Both variables are squared. They're going to have different numbers, and they're going to have the same signs. So here's what I mean by that. For ellipses, we're going to have a plus sign in the middle, and when you have the parametric equations, these numbers out front are always different, and if you're trying to complete the squared, everything would be all positives. Alright, so for ellipses, a couple things we wrote down here is that A is always the biggest. I'm going to use the back equation if I'm trying to find a missing variable. A will give me the distance from the center to the vertex, B will give me the distance from the center to a covertex, and C is going to give me the distance from the center to a focus. If they tell me anything about the major axis, it's always 2 times A, and the minor axis is always 2 times B. Okay, so let's go see what we have over here. I know it's an ellipse because there's a plus sign. Because it's an ellipse, I know that the A is always the biggest number, and my biggest number in the denominator here is the 25. So I look above the 25 and I see a y, so I know the biggest denominator is going to also tell me the direction. So this is going to be a vertical ellipse. This number right here, 25, that's my a squared, so a is 5. The other denominator is b squared, so if b squared is 4, b is 2. There are no parentheses, so my center is at 0, 0. So I'm going to go graph the center at 0, 0. Because it's vertical, I'm going to go the A distance up and down. So I'm going to go up 5, that's a vertex. I'm going to go down 5, that's a vertex. So my vertices are 0, 5, and 0, negative 5. To graph the rest of the ellipse from the center, I'm going to go left and right 2. Those are my co-vertices. I'm going to go connect my points. There's my ellipse. The other thing they asked me for right here is the focus. In order to find the focus, I have to know C, and I'm going to go C distance vertically because it goes the same direction as your vertices. So to find C, I go back to my foldable, and it says b squared equals a squared minus c squared. So b squared equals a squared minus c squared. So 4 equals 25 minus c squared. So c squared equals 21. So c equals the square root of 21. So from the center, I'm going to go up the square root of 21, and I'm going to go down the square root of 21, which is going to be somewhere between 4 and 5. You can use your calculator. So a little above, a little below the 4. So my focus is going to be up square roots of 21, comma 0, and down square roots of 21, comma 0. The last thing they want me to do is the parametrics. So again, I come over here and look at my formula. It's a vertical. So to do the parametrics, x gets cosine, y gets sine, and then I'm just going to do the a and the b right here with it. So I need a pair of equations, x equals, y equals. I come up here and I look below my x and I see a 4. That means b is 2. I look below my y and I see a 25. So a is 5. X always gets cosine. Y always gets sine. Because I'm at 0, 0, I don't need to add anything. Number 6 is also an ellipse because there's a plus sign right here. And because it equals 1, I'll notice this time that I do have parentheses, so my center is not at 0, 0. When you write the center, you pull the opposite out. That says plus 2, so my x-coordinate is negative 2. It says plus 1, so my y-coordinate is negative 1. In order to figure out the direction, I go find the biggest denominator. The biggest denominator is 16, and it's below the x, so this is a horizontal ellipse. Remember, your biggest denominator is your a squared. So if a squared is 16, a is 4. The other denominator is your b squared. If b squared is 9, b is 3. So I'm going to go graph my center at negative 2, negative 1. There's my center. and I'm going to go left and right this time, a distance. So I'm going to go 1, 2, 3, 4 to the right, and that's going to give me one vertex, and that's at 2, -1. And I'm going to go 4 to the left, 1, 2, 3, 4, and that's going to be at -6, -1. And those are my vertices. I'm going to go up 3 from the center, so 1, 2, 3, that's a co-vertex. I'm going to go down 3. I'm going to go connect those points for my ellipse. The next thing I want is the focus again. So I'm going to use that same formula we did up top to find C. We're going to have b squared equals a squared minus c squared. My b squared is 9, a squared is 16, so c squared equals 7, so c equals the square root of 7. So square root of 7 is a little less than 3, but more than 2. So from the center, I'm going to go right the square root of 7 and left the square root of 7. So remember, my center doesn't start at 0, it starts at 2. So from the 2 coordinate, I'm going to go right the square root of 7. And from the 2, I'm going to go left the square root of 7. For parametrics, again, I need an x and a y. I look at the x, and below it I see a 16, so I write down 4. I look at the y, below it I see a 9, so I write down 3. X always gets cosine. Y always goes with sine. This time I have a center that's not at 0, 0. When you're writing the parametrics, you don't do the opposite. I write exactly what it says. My x coordinate is -2, so I write down -2. My y coordinate is -1, so I write down -1. Okay, I'll turn my review over, and now we're looking at circles. So I look at the circle part of my foldable now. For circles, both variables are squared. This is my rectangular formula. This is my parametric formula. For your parametrics, the r's both go out front. That's why it says it's the same number out front. They're both going to be positive. It always equals r squared. Okay, so for the circle, I'll notice that I have parentheses, so I'm not at 0, 0. And when we write the center from the rectangular, I always have to pull out the opposites. So it says -3 in there, so it's a +3. It says -4, so it's a +4. So my center is at 3, 4. This is always your r squared. So if r squared is equal to 9, the radius is just 3. So to graph this, I would go to 3, 4, 1, 2, 3, 4. And from the center, I would go up, down, left, and right 3. So I'd go up 3, 1, 2, 3, right 3, 1, 2, 3, left 3, and down 3. And then I just go connect my points and make my circle. I'm sure your circle looks way better than mine. Okay, so for the parametrics, the r's go first for both of them. And again, we have an x equal and a y equals. My r is 3. Cosine still goes with x. Sine still goes with y. For your center, you write down exactly what it is. So the x coordinate is a +3, so I write +3. My y coordinate is a +4, so I write +4. Number 8 wants me to write the equation of a circle in standard form. That means rectangular form with a radius at 3 and a center, HK means center, at 0, 0. Because I'm at 0, 0, I don't need any parentheses. I'm just going to have x squared plus y squared. And it always equals whatever r is squared. If r is 3, it's going to equal 9. On number 9, it's the exact same type of equation, but this time my center is at -2, 4. So I'm going to need parentheses. Your x coordinate is going to go in the first parenthesis. Your y coordinate is going to go in the second parentheses. Because I'm going into rectangular with parentheses, I'm going to write the opposite in here. The opposite of -2 is +2. The opposite of +4 is -4. And again, it always equals r squared. If r is 5, it's going to equal 25. The last thing we covered were hyperbolas. So here's my hyperbolas. Again, they're both squared, but this time there's a subtraction sign in here. And you have a new equation to find your missing variable. This time it's c squared equals a squared plus b, c squared equals a squared plus b squared. And for this one, a is not always the biggest. Look what it says, a is always first. So for ellipses, a is always the biggest denominator. But for hyperbolas, a squared is always first. All right, so number 10, the very first letter written is X. So this is a horizontal hyperbola. A squared is always written first. So if A squared is 49, A is equal to 7. This is over an imaginary 1, so B, the square root of 1, is 1. There's no parentheses, so again, my center is at 0, 0. So from 0, 0, because it's horizontal, I'm going to go right 7, and I'm going to go left 7. Those are your vertices. So I have a vertex at 7, 0, and negative 7, 0. From the center, I'm going to go up 1 and down 1, and then we're going to have a really skinny rectangle. Remember, this rectangle is used to make your asymptotes. And this tells you how skinny or wide to make your hyperbola. So you're going to go to your vertex, and you're going to open up as wide as those asymptotes on both sides. And the last thing they asked me for is the focus. Your focus is going to go the same direction. It's going to go left and right. It's going to go left and right a distance of C. So I have to go find my C. C squared equals, here's my little formula again, A squared plus B squared. So A squared is 49. B squared is 1. So C squared equals 50. So C equals 5 square roots of 2. And don't stress about if you remember how to do that. Square root of 50 is fine. Because you're at 0, 0, and I'm going left and right, I'm going to go right 5 square roots of 2, and I'm going to go left 5 square roots of 2. So there's going to be my focuses in there. When you write your parametrics, this one's different. You're still going to have x equals and y equals. You're still going to go to the x and look below it. I see a 49, so x gets 7. I see go to the y, look below it. I see a 1, square root of 1 is 1. What's different is I don't use cosine and sine anymore. Whatever direction it goes gets the secant. Because this goes left and right, x gets secant, and y is going to get tangent. This is only for hyperbolas. Because I'm at 0, 0, I don't have to write anything right here. Okay, let's go to another hyperbola. So again, I look at what's written first. This time written first is the y. So this is vertical. And remember, a squared is always first. So if a squared is 36, a is 6. B squared is second, so b squared is 4, so b is 2. No parentheses, so I'm at 0, 0 again. This time I'm going to go up and down 6 because it's vertical. So up 6, down 6. So my vertices are at 0, 6, and 0, negative 6. I'm going to go left and right 2. I'm going to make my little box. Remember, that gives me the asymptotes. It tells me how wide I can make the arms of the hyperbola. And the last thing I need is my focus. So again, I'm going to use that same formula, a squared plus b squared. So c squared equals 36 plus 4. So c squared equals 40. So c equals the square root of 40, which is 2 square roots of 5. No, it's not. It's 2 square roots of 10, sorry. Because I've got 4 and 10, 2 and 2, 2 and 5. Couples go out, singles stay home. So from the center, I'm going to go up 2 square roots of 10, and I'm going to go down 2 square roots of 10. So for the parametrics, again, we're going to have an x equals and a y equals. Below the y, I see a 36, so y gets 6. Below the x, I see a 4, so x gets 2. Because it's vertical, the y gets the secant word, and x gets tangent. I'm at 0, 0, so I don't need to write anything. Number 12, write the equation for a hyperbola with vertices at 2, 0 and negative 2, 0. So there's a vertex, and there's a vertex. Because my vertices are going left and right, I know my equation has to start with x equals. It's a hyperbola, so I have to have a minus, and it has to equal 1. I know a squared always comes first, and a is the distance from the center to the vertex. Well, I can tell the center is at 0, 0 because that's directly between these 2 points. And a is equal to 2, so a squared is 4. To finish the problem, I simply need to know what b squared is. And I've got this formula that we're going to use again. So I know that c squared equals a squared plus b squared. They tell me the focus, and when they tell you the focus, they're also giving you your c. 1, 2, 3, 4, 5, 6. So the distance from the center to the focus tells me that c is 6. And I know a is 2, so I can use this formula to find b. So we're going to have 36 equals 4 plus b squared. I'm going to subtract, and b squared equals 32. Down here in the formula, I actually need b squared, so I'm done. The next section, these are giving you parametric equations, and they're wanting you to write the rectangular equation and then tell me, is it an ellipse, a circle, or a hyperbola? So when you're doing these, the first thing I'm going to notice is that these two numbers are not the same, so I know it's not a circle. And I don't see the word secant or tangent, so I know it's not a hyperbola. So I know it has to be an ellipse. Remember, you write your center back here at the back, and since there are no numbers there, that means the center is at 0, 0. If I were to write this equation, all ellipses have the x squareds first, and it always equals 1. Because my center is at 0, 0, I didn't need any parentheses. A squared is going to be your bigger number. So what's bigger, 3 or 6? 6 is. So underneath the y goes 6 squared, which is 36. Underneath the x is going to go 3 squared, which is 9. They ask you for the length of the major axis, which is always 2 times a. Remember, a is your biggest number, so a is 6, and 2 times a is 12. On the back of the review, we're doing the exact same thing. Again, I see these numbers are not the same, and I see that it's not secant or tangent, so again, it's not either one of these. I can see that 4 is bigger this time. So that's my A, this is my B, and my center is not at 0, 0 this time because there's numbers at the back. The center is at 3, -2. For ellipses, the x always comes first, and it's always a plus. It always equals 1. The bigger number is going to go with the x this time. So if A is 4, that means A squared is 16. B squared would be 4. When you go to write it into rectangular, you have to do the opposite. So if the center is at 3, I put a -3. If the y center is at -2, I put a +2. Number 15, I see the word secant and tangent. So that tells me right away it's not an ellipse, it's not a circle, it has to be a hyperbola. With hyperbolas, we're always going to have a subtraction sign in the middle. With hyperbolas, the bigger number tells me which one to write first. Y had the bigger number, that means y squared goes first, x squared goes second. This is my A, so this is 16. This is my B, so this is 9. My center is at 0, 0, because there's nothing written at the back. Because I wrote the y first, it's going to be vertical. Oh, I forgot to insert that up here. Because the bigger number was 4, it's horizontal. Okay. Where was I at? Oh, the length of the major axis is always, oh wait, I'm sorry. I'm putting these in the wrong spot. Vertical, 0, 0. The length of the transverse axis is also 2 times A. A is 4, so it is 4 times 2 is 8. Number 16, I see tangent and secant again, so I know it's a hyperbola, so it's not either one of these. There's nothing written at the back, so the center is 0, 0. I see that secant has the word with the Y. Ooh, I did this wrong up here. Come back here. This is not the bigger number. I was thinking ellipse again. Wherever secant is going to tell you the direction. So since secant is with x, this is actually a horizontal. My fault, guys. So the x squared comes first, the y squared comes second. Underneath the x, I put the 3 squared. That didn't change. Underneath the y, I put the 4 squared. That didn't change. It still equals 1. So secant's going to tell you the directions. My fault. The a squared always comes first. That means a is actually 3. And it also means that it's not horizontal. And it means 3 times a is 6, not 8. Gosh, I'm sorry, guys. That's my fault. Okay, so down here at 16, let's do it again. The secant is with the y, so it's a vertical. And that means that the y squared comes first. If I look under the y, I'm going to see a 4, so 16 goes here. In front of the x, I see a 2, so 4 goes here, and it always has to equal 1. My center is at 0, 0, because there's no parentheses, nothing's written back here. This is always 2 times a, and a is always written first now, so a is 4, that means this is 8. All right, almost done. These last two, I'm going to see that the 3 is, they both have a 3 out front. That means it's a circle because the numbers are the same. There is something written at the back, which means the center is at 1, 2. Your radius is always written first, so your radius is 3. Because it's a circle, it's always going to be the center, which is the opposite. So x minus 1, y minus 2, and it always equals r squared. Okay, one more. These are both an 8 out front, so again, I know it's a circle because they're the same. The back numbers give me my center. My center is at -7, +1. The numbers in front give me my radius. My radius is 8. So when I go write my equation, we're going to have x plus 7. I do the opposite. Y minus 1. I do the opposite. Then it equals 8 squared. 8 squared is 64. Okay, guys, I hope the review helps. Study hard. See y'all tomorrow.